Hi everybody, I'm Mr. Radha. We are doing some online courses for computer science A-level paper free. Our topic today is Karnaugh Map. Okay, this is me. Guess where I am? This is Karnaugh Map. Okay, our main topic. So we are going to understand what is Karnaugh Map. Okay, and the benefits of Karnaugh Map and how we will use Karnaugh Map to solve Boolean expression. So to simplify Boolean expression, there are two ways. One using the Karnaugh Map, second one using Boolean algebra. So why we use Karnaugh Map is to reduce the Boolean expression. Why we reduce the Boolean expression? To create simpler circuits, to reduce complexity. A circuit which consumes less power and will faster to run. Next, what is Karnaugh Map? It is a graphical method of reducing Boolean logic or Boolean expression. And we do not need to memorize many rules like in Boolean algebra. Now, what are the steps for simplifying the Boolean expression? You have first to draw the K-map, populate the K-map, group the adjacent ones, analyze the groups, and reduce the Boolean expression. So these are the steps we are going to look at. Now, two variables. Let's look at Boolean expression with two variables. What are our two variables? A and B. And we have four combination. 1, 2, 3, 4. Four combination. And here is our K-map. This is our truth table and this is our K-map. Now we have to convert the truth table to a K-map. The first term A0, B0. So A here we have A0 and A1 here. So the first term A0 means this one and B0 is this one. So A0, B0 is a 0. Next A0 and B1. So this is A0 and B1. This is a 1. Next A is 1 and B0. B0 is this one. B0 is this one. It's a 1. Next we have A1 and B1. So A1 is here and B1 is here and the output is 1. So this is my output. So you have learned from the truth table how we draw the K-map. Let's look at it and we will use the K-map to reduce our Boolean expression. So earlier our Boolean expression was this one. Later on I'll show you how to use the K-map to reduce it, make it simpler. Okay, it's just f is equal to a plus b. Let's look at another example. This is our Boolean expression. We have two terms. These are our two terms. Okay, so two places we are going to have our two inputs and our two terms. Our truth table is here. Now we use the truth table to draw the K-map. This is our K-map. Okay, the first term A0 and B0. So A0, B0 is 0. Next A0 and B1. So A0, B1 is 0. Put a 0 here. Now A1, B0. A1 and B0 is a 1. So we are done with it. Next A1, B1. So A1 and B1, the output should be 1. So I have put 1 here. So if we follow the order, this is the first, second, third, fourth. So first, second, third, and fourth. So we have drawn the K-map. When we are done with the K-map, we learn how to reduce simplify the Boolean expression, and we'll get z is equal to a. So earlier the Boolean expression was this one. Okay, now we using the K-map, we'll reduce it to a simple one, z is equal to a. So we have reduced the Boolean expression, but later on I'll show you how to reduce. Now what we are learning, so let's look at example 3. This is our Boolean expression. How many terms we have here? 1, 2, 3 terms. In between we have the plus. So this is our Boolean expression. Z is our output. So we have two inputs, A and B. And Z is our output. Okay, and we have 3 terms, 1, 2, 3. And we have 3 places, we have 1. Okay, so now let's look at it. The first one, A0, B0. A0, B0 is a 1, so we put a 1. Next, A0, B1. So A0, B1, we have a 1, so we put a 1 here. Next, A is 1, B0. A is 1 and B0 is this term, say 1. We are done. Now last one, A is 1, B is 1, the output is 0. So A is 1, B is 1, the output is 0. So you have learned how to convert the truth table, so this is our truth table, into a K-map. And later on we'll use a K-map to reduce the Boolean expression. So this is a simplified Boolean expression. Earlier we had a long Boolean expression, now we have reduced it to a simpler one. Next, let's look at example 4 now. You have 2 variables. So this is our Boolean expression. The inputs are A and B, and the output is X. We have 2 terms. These are our 2 terms. Okay, this one and this one. Now this is our K-map. Our K-map, we have A dash means 0 and A is 1, B dash means 0, okay, and B is 1. Now A0, B0. So A0 and B0, the output is a 1. So we have put a 1 here. Now A0, B is 1. A is 0 and B is a 1. The output is a 0. Next, A is 1, B is 0. A is a 1 and B is a 0. This one, the output is a 0. We are done with it. Last, A is 1, B is 1. So A is 1, B is 1. The output is a 1. We have done with it. So we have these 2 terms, and the 1 means the 2 terms here. So we have converted the truth table into a K-map. Okay, so this is our Boolean expression, this is our truth table, and this one is our K-map. Later on we'll group the one in the K-map, okay, to reduce the Boolean expression. Next, let's look at free variables. So these are our free variables. Now remember, free variables is 2 to the power of 3. 2 to the power of 3 means 8 combination. So these are my 8 combination. 4 and 4 means 8. Now let's look at the Boolean expression. The Boolean expression, you have 4 terms. 1, 2, 3, 4. These are our 4 terms. 1, 2, 3 and 4 terms. That's why we are going to have 4 ones. 1, 1, 1, 2, 3 and 4. Now let's look at the combination of the, okay, let's look at the combination. So this is A, here we have A0, A dash means A0, B dash means B0, A dash means A0, A B is 1, and this is 1 0 and this is 1 1. So like this is 0 1 2 3. We have done a swapping here. We have swapped, and here C0 is 1. This is C0. C dash means C0 and C means 1. So you have to remember these two terms we have swapped. Okay. Now okay. Wait now. So we go back to this term. So again, let's do it like this: 0 0 0 1 1 0 and 1 1. Means we have swapped. We have taken last one. We have swapped it with the other one. Now let's look at this one. C0 means C dash means 0. This is 1. A0 B0 C0 is here. A0 B0 and C0. This one is a 1. So we are there. Now again, A0 B0 and C is 1. So A0 B0 and C is a 1. This one is a 1. Okay. Then now A is 0, B is 1 and C is 0. A0 B is 1 and C is 0 is this one. Say 1. Okay, next it goes like this. This one becomes the 4th term. This one becomes the 5th term. This one becomes the 6th term. And this one becomes the 7th term. And this one the 8th term. So what you learn here, this one is the 1st term, 2nd term, 3rd, 4th, 5th, 6th, 7 and 8, like this. 1 2 3 4 5 6 7 and 8. We go faster like this. Now let's look at if instead of using the vertical this one, we could have used the horizontal way. I mean this one A0 B0 0 1 1 0 and 1 1. C dash means 0, C is 1. So now if you go this way, this is our 1st term, 2nd, 3rd, 4th, 5th, 6th. Okay, so we have swapped these two colors. Then become 7 and 8. Okay, this is how we convert the truth table into the Kiva. Now let's look at the 4 variable. What's complex? It is easy. Okay, now 4 variable means 2 to the power of 4 means 16 combination. Okay, this is our 16 combination, as you can see. So 4 4 4 4 4 times 4 makes 16. Now our Boolean expression is x is equal to, we have 4 terms, 1st, 2nd, 3rd and 4th term. So we have 4 places. We have 1, this one 1 place, 2 place, 3 place and 4 place. Now let's say this, we put AB on this side, okay, CD on this side. Okay, now 0 0 0 1 1 0, swapping. Now swap these two. This is 1 1. Here again 0 0 0 1 1 0 and 1 1. We have swapped these two. Now the order that we have worked, it's not difficult. you look at this one, okay, this is A0, B0, C0. So A0, B0 and C0 but D1. Okay, we can disturb. Next, A0, B1. A0, B1. A0, B1. Okay. And then C0 and D1. C0 and D1 this way. So you go this way and this way. This is the second one. Now this one A is 1, B is 1. So A is 1, B is 1 this way. Okay. And C0, D1. C0 and D1 this way. So if you go this way, this becomes your next one. Now let's try this one, last one. A, B both 1, C, D 1. So A, B is 1 is this row and C, D 1 is row. So that's why we got the photo. But one way to remember this is the order, like first one with this one 0, then it goes, we can go this way because E is 0, B 0, E 0, B 0, so E 0, B 0, it goes this way. So 0 here, then 1, then 0, 0, 0, 0, and next is 0, then 1, and 0, 0, 0, 0, and then 4, 0, 0, 0, 0, 0, then comes 0, 1, so 0, 1, then 0, 1, 0, 1. So there is an order that we can follow. Okay, let's do something else now. Okay, okay. Okay, let's do it again if you want. So we go like this: 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, then 4, 0, 0, 0, sorry, 0, then 0, then 0, 1, 0, 1, and 0, 1, 0, 1. You can see I have written the orders 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can follow this order if you want. Now let's look at something else now. Okay, so another way of looking at it like this: we have AB on this side and CD on the other side. This is 0, 0, 0, 1, 1, 0, and 1, 1. This is 0, 0, 0, 1, 1, 0, and 1, 1. The order that we should follow is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we swap the rows, okay, and also we swap the columns. interchange. So these two columns we can interchange, and these two rows we have to interchange the order. Now let's look at grouping. Okay, so when we have drawn the K-map, we have to simplify it, we have to group it. So what is grouping? We group, we minimize expression. Now the ones in the K-map, the ones, we try to group them into groups of 1, 2, 4, 8 and 16, that is powers of 2. The adjacent cells we can put it in the same group. Okay, and we try to do the largest group as possible and the smaller number of groups. So make big groups and larger groups. Okay, each one on the map must be included in at least one group. And if a one is already in a group, it can be included in another group as long as the overlapping group include a non-common one. Okay, you're going to learn this now. Let's look at this diagram. These two ones are next to each other, they can form a group. Okay, so this one, you have two terms. First term is A dash B C dash, and the second one is A B C dash. Okay, so these are our two terms. Now when you look at these two terms, what is changing in these two terms? A is changing from A dash, A becomes A, so we can eliminate the A. And what is the same? B and C dash is the same, so we keep the B and C dash. So this is how we got a simplified version of this one. X can be simplified as B C dash. Let's look at these two. This one now. These two terms can be grouped. Now the first term, this one, is A dash B C dash, and this term is A dash B C. Now what is changing in this? What is changing is C dash and C cancel. What remains the same? A dash B. So we have A dash B. This remains the same. This one we can remove it. Now let's look at this diagram. These two can form a group, and these two also can form a group. Why? Because when we fold it, these two can sit next to each other. This one and this one. If we fold it horizontally, they will be sitting next to each other. So we have two groups. This is one group, this is another group. In this group, the first one, these are our terms. This is A dash B dash, this one is A dash B dash and CD, and this one is A dash B dash and CD dash. Now in these two groups, you can see that A dash B dash remains the same, but A dash B dash remains the same, C also remains the same. What is changing? D from D and D dash. So we can eliminate the D. So what remains is A dash B dash and C. Now the next group, if we look at this group now, this one is A, B dash and C dash and D dash. Now this one is A, B dash, C, D dash. Now what is changing in this one now? We can see that C is changing from C dash to C. What remains the same? A, B dash and D dash. So C should go now. Here we have to correct it. It's A, B dash, and D dash. So finally, originally we had four terms, 1, 2, 3, 4. This has been reduced to 2 terms. What are the 2 terms? This one plus this one. So we have reduced the Boolean expression. Now let's look at this diagram now. We can form a group of 4. Okay. Now originally we had 4 terms. 1, 2, 3, 4. Now we form a group of 4. Now what is changing? A and B is changing. A and B is changing. What remains the same in all the 4 groups is C. So the simplified version X is C. Let's look at this one. We have 4 terms. 1, 2, 3, 4. What does not change here? It's AB. Everywhere it's AB. AB, AB, AB. But what is changing? C dash changes to C. D dash changes to D. So finally we have X is equal to AB. We have reduced the Boolean expression. Now let's look at this one. What we have a group here. We can overlap, we can fold it. These two can be sitting next to each other. We can form a group of 2 ones here. Now what is not changing here? C dash is not changing, so that's why X will be C dash. Now A is changing and B is changing. Let's look at group of 4. We call these 4 corners. These 4, when we fold it, okay, vertical folding, this one will be sitting to make this one, and horizontal folding, all these can be sitting next to each other if we fold it horizontally and vertically. So this Boolean expression will reduce to X is equal to B dash and D dash. Now this one also can form a group of 4, and the Boolean expression will be reduced to X is equal to D, B, D, because BD is not changing. C and D, A and C is changing. Let's look at this one now. Again, this one we can group them. When we fold them, we can form, instead of forming 2 groups of 2, we can form a big group, 1 group of 4, and then the Boolean expression can be reduced to X is equal to AD, because AD is not changing. Look at this one now. We can group these 4 in a group of 4. Remember, we can form groups of 1, 2, 4, 8, and so on. Now let's look at group of 8. You can see this one. They are sitting next to each other. We can have a group of 8, and what is not changing? X is equal to B. This one again, we can form another group of 8. They are sitting next to each other. So X is equal to C dash. C dash is not changing. Let's look at another example now. If we fold it, this 4 and this 4 can form one group of 8, and the answer will be X equal to B dash. Okay, let's group this one and this one, sorry. So it can be a group of 8, and the answer will be X equal to D dash. Now let's look at how we simplify this one. This is a group of 4, so we have formed a group of 4 in blue, and then we can overlap this one with this one, form another group of 2. So in fact we have 2 groups. We have 2 groups here. Okay, You can see we have two groups. We have a group of 4 in blue, okay, and also we have a group in red, a group of 2. Now the group in red have 2 terms. You can see you have 2 terms. This is first term and second term. We write the term. So this is my first term, this is my second term. You can see what is changing. B is changing from B dash to B. So we can cancel the B. What is not changing? A dash and C dash. So we keep this. Now let's look at the group of blue. The group of blue, we have 4 terms. This is our 4 term, 1, 2, 3, and 4. We can see that A is changing, C is changing from C dash to C, C dash to C. But what does not change is B. So the simplified version will be B. So 2 groups means the red one remains, group of red and group of B. So we have reduced it into a Boolean expression, simpler one. So we have 2 groups. These our 2 groups are left. So originally there was a complex Boolean expression of how many terms? 1, 2, 3, 4, 5 terms. So the complex Boolean expression of 5 terms has been reduced, let's say Z, into 2 terms, 1 and 2. Okay, let's look at another example now. Let's say we create a group of red. Okay, this time a group of red. Now I can overlap the one with another group where I'm introducing a new element in it. So this is another group, the green one. Now I have a 1 here. I can group it with 1. I can overlap it to form a third group. So we have 3 groups, groups of blue, groups of red, and groups of green. And in each group I have 2 elements. So let's look at the blue one. The blue one has 2 elements. What is changing? C, we can cancel it. What remains is AB. Let's look at the red group. We have 2 terms. What is changing? A is changing, A dash to A. What remains the same is BC. The third one, we have 2 terms. The green group of green, what is changing is B. What remains is AC. So finally, the output, let's say Z, the output Z is equal to AB plus BC plus AC. So this is our simplified Boolean expression. So what you have learned, summary. No zero are allowed in a group. No diagonals are allowed. And the groups should be powers of 2. And groups should be as large as possible. And every one must be in at least one group. Overlapping is allowed if we introduce a new one. Wraparound is allowed. You have vertical wrapping and horizontal wrapping. And try to make fewer number of groups as possible and larger groups as possible. So these key terms, these key ideas you should remember when reducing and grouping the K map. Now, what is allowed and what is not allowed? You can see we cannot group a 0 with a 1. This is wrong. And what is right? We can group 1 with 1, a group of 2 elements. Diagonal groupings are not allowed. Okay, it's wrong to do that. Okay, we can form a group of 2, another group of 2. That is right. But we cannot form a group of 3. Remember this. So this is our group of 2. We are not, this is right, but we are not allowed to form groups of 3. Now groups of 4 so is allowed. Okay, this is right to say. But here groups of 5 is not allowed. We can't say 1, 2, 3, 4, and 5. So this is not allowed. Next. we can form two groups here, a group of 4 and another groups of 4 here. Okay, this is right. But this one, why? Group 1 group, 2 group, 3 groups. So this is wrong, because we could have formed a bigger group like this, large, and another larger group like this. So try to form larger groups as possible. So okay, so we can overlap. Okay, groups can be overlapped. One group we can overlap with another group as long as we introduce new terms. Okay, the corners 1, 2, 3, 4 can form a group of 4. Okay, and these are a few resources when you can get some notes. You can go for it. These are a list of exam questions you can attempt. Now let's look at this exam paper. Okay, how we solve. This is November 2015, paper 2033, question number 5. Okay, okay, okay. Now what is given to you? The truth table is given to you. So this is a truth table. We have 3 inputs. What are our 3 inputs? A, B, C, and our output is X. So 3 inputs mean to the power of 3 means 8 combinations. There are 8 combinations. So it's easy to write. The Boolean expression. How we write the Boolean expression? Let's see now. Okay, it's not difficult. You see where there is a 1, 1, 1. So when there is a 1, you can easily write the Boolean expression. So the Boolean expression, this one is given to you. This is A dash, this is B, this is C. So A dash, B, and C. This is given already. Now, next one is A, B, and then C dash. So plus E, B, C dash plus. Let's look at the next one now. Okay, wait. Next one is A, B, and C because it's a 1. So A, B, and C. So it's not difficult. It was an easy question. The answer was given below. Let's check this one. Okay, it was given. This one okay, and this one okay. Okay, let's go for next question now. We have to fill the K-map. The K-map is already given. The variable AB 00, 01, 10, and 11. C0 here and C1 here. Now let's look at the term now. The first term is A0. Wait, sorry. A0. Okay. And what happened now? Okay. So wait. Okay. Let's write it again. So this one becomes A dash BC. So A0 then BC. A is 0, then B is 1, and this is our C. This one becomes a 1. Okay. Next is Next term is we find that this one and this one 0 0 0 0 0 and 0, because the next term is supposed to be okay. It was plus a b c dash plus a b c. Okay, so a b c dash. So this is my a b, then c dash. This one, it should be a 1. Then a b and c. This one, a b and c. This is a is 1, b is 1, and c is 1. Like this one. Okay, we are done with this. Let's check the answer. Answer is correct. Okay. Next, we have to group them. Okay, let's see how we group them. Okay, we have our terms. We have to group them. We can form a group of 2 and a group of 2. Okay, so this is the answer. Now, we have to reduce the Boolean expression now. How we reduce it? Let's work it out. This group of 2, what is not changing here? AB is not changing, but C is changing from C to C dash. So AB remains the same. We write AB here plus this one. What is not changing? C is not changing. C is 1 in both cases, so there must be a C. Okay. And what else not changing in this case? In these two, what is not changing? The B is not changing. So the answer will be wait, yes, AB and then plus BC. Try it, it's not difficult. Now let's look at part. Let's look at part B now. In part B we have 3 inputs A, B, C, D. So 2 to the power of 4 belongs 16 combination. And in our 16 combination, we have how many ones? 1, 2, 3, 4, 5. Okay, 5 ones. Now, when we look at the K-map, it's easy to feel. This is 0, 0, 0, 1, and 1, 0, and 1, 1. This is 0, 0, 0, 1, 1, 0, and 1, 1. Now, you have to see where you have to fix these ones in this one. 1, 2, 3, 4. Sorry. 1, 2, 3, 4, 5. So you look at the combination. Okay. Do one for you. A is 0. B is 1. So when you burn them up, A is 0. B is 1. This one. And then D0, C0, and D0. So you go like this. D, C0, D0 this way. So this one should be a 1. Okay. Next one, you fill it like this. AB, A0, B1. A0, B1, this one. And then C1, D0. C1, D0. Okay, this one. So this one is 1. Okay, like this you will have other terms. You try it, and then those other cells will be zeros like this. 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0. Now what you have to do, you have to form the groups. So this is the answer set. Okay, we are done with this. Now we have to throw the groups. How many groups can we form? Let's see. We can have a group of 2 here, another group of 2 here, another group of 2. So finally we will be left with 3 terms. Okay, we are done with this. And finally the answer will have the 3 terms. First term plus the second term plus the third term. Now we see first term will be b, d dash is not changing, and then we have, let's look at it. Wait, no, sorry, mistake. We can have a group of 4 here. So we have 2 groups, a group of 4. Okay, so the group of 4 will reduce what is not changing is b and d dash. Then we have another group of 2 here, and this will be reduced as a, b, c. So we have only 2 groups. We don't have 3 groups here. So I will clean this part, clean this part. Okay, so again clean this. So we have 2 groups. We form a group of 4 because we can fold it vertically. So the group, this one will give this result because this will not change. Okay, let's look at it. Wait now. What has happened now? Where is the notes? Okay, get back to this work. Okay. Wait.